Right, welcome back to the Explainer. Today we're unpacking the exact toolkit you need to build absolutely massive, highly scalable web applications. We're really looking at that invisible infrastructure that keeps the modern internet from completely crashing when millions of users hit a system all at once. So let's look under the hood.
Here is our roadmap for today. We've got day 7, system design, routing with DNS, CDNs, and edge servers, static versus dynamic content, reverse proxies explained, and finally, designing the mini project. We're essentially going to follow the chronological journey of a user request to see exactly how all of this connects.
Okay, kicking things off with section 1, day 7, system design.
Now, when you look at this cluster of technologies, DNS, reverse proxies, CDNs, edge servers, and concepts from platforms like CloudFront and Cloudflare, you have to realize they aren't just isolated buzzwords. No way. They are a highly coordinated relay team. Literally, every time a heavily trafficked app loads, these elements are firing off in a fraction of a millisecond. And today, we're going to slow that millisecond way down.
Because mastering this relay team is absolutely crucial. It's how we unlock our ultimate goal, scalable web application architecture. We aren't just memorizing definitions here, right? We are gathering the literal blueprints you're going to need to handle millions of concurrent users for our upcoming mini project.
So, let's see how this journey begins with section 2, routing with DNS. When a user tries to access your app, DNS is that fundamental routing system, the absolute first step. But at scale, DNS does way more than just translate a domain into an IP address. Think of it as an insanely intelligent global dispatcher. It uses latency-based or geolocation routing to instantly calculate the absolute fastest, healthiest data center to send your user to, all before their journey even truly begins. It's kind of mind-blowing.
Which brings us to section 3, CDNs and edge servers.
So once DNS routes the request, we had a literal physical problem. Geography, right? You just can't beat the speed of light. If your main server is sitting in New York and your user is tapping away in Tokyo, that data takes time to travel, and that causes latency. To scale properly, you cannot have the whole world knocking on one single server's door. You absolutely need a distributed network, and that's where content delivery networks, edge servers, and concepts from Cloudflare and CloudFront come into play.
This is where those edge servers really shine. By placing servers physically closer to the user, literally at the extreme edges of the network, we cast this massive global net. So that user in Tokyo, they just hit a Tokyo edge server. That server rapidly catches and processes the traffic before it ever hits your main infrastructure. It serves requests instantly and drastically reduces the compute load and egress costs on your end. It's a real game changer. All right, let's move to section 4, static versus dynamic content.
As that user's request hits the CDN, your architecture has to make a routing choice. And to scale effectively, it must differentiate between static and dynamic content. Static assets, think unchanging stuff like images, basic HTML files, videos, they're identical for everyone. Edge servers cache those and hand them out instantly without ever touching your backend. But dynamic content, say a live shopping cart or a personalized banking dashboard, that's user-specific. Edge servers can't just hand out generic copies of that. It requires actual real-time backend processing.
Which leads us perfectly into section 5, reverse proxies explained.
For those complex dynamic requests, the traffic has to travel deeper into our system, and we use a reverse proxy. When global traffic floods in, you simply cannot expose your internal servers directly to the open internet. It's too risky. The reverse proxy acts as this intelligent shield, the ultimate traffic cop. It sits in front of your internal servers, handles SSL termination, manages connection pooling, and uses load balancing algorithms to distribute all those incoming dynamic requests safely and efficiently. Your users only ever interact with the proxy, which keeps your core infrastructure safe, hidden, and highly available.
All right, it is time to bring this all together in section 6, designing the mini project.
Everything we've just covered in this Day 7 syllabus culminates right here in building our scalable web application architecture mini project. You now understand the full life cycle of a scalable request, so it's time to step up and act as the system architect.
By stacking these concepts sequentially, we build a truly unbreakable system. Think about the flow. Step 1, intelligent DNS routes the user. Step 2, we utilize CDNs and edge servers like Cloudflare or CloudFront, casting that global net to absolutely kill latency. Step 3, we neatly separate our static versus dynamic content, serving those static assets instantly right from the edge. And finally, step 4, we funnel all that heavy lifting dynamic traffic through a reverse proxy to distribute the backend load safely.
Mastering this sequential flow, that is the golden rule of modern architecture. The internet is only getting bigger and user demands are just getting faster. Understanding how to orchestrate these systems isn't just theory anymore. It's exactly what separates a site that completely crashes under pressure from one that flawlessly scales to millions. So I want to leave you with this to consider. How will you apply these specific Cloudflare and CloudFront concepts to design your own highly scalable web architectures? Take these blueprints, start building, and I will catch you in the next explainer.